Hello to all new students. In this video, we'll be discussing about one-tailed and two-tailed test. Let us try to understand this with the help of an example. Okay, so the example is, suppose this is an ice cream making machine and it is said that it is being assumed that this machine is making cup ice cream that weighs 5 grams. Okay, this machine is making 5 grams of cup ice cream and this is our null hypothesis. A worker claims that after maintenance, this machine is no longer making cup ice creams of 5 grams weight, and this is our alternative hypothesis. So you'll write this in this manner: H naught, that is your null hypothesis, mu, that is average weight, is equals to 5 grams, whereas HA, that is the alternative hypothesis, mu is not equals to 5 grams. See, whenever alternative hypothesis doesn't equal to some value, then you are going to have a two-tailed test. Okay, listen to this point very carefully and try to remember this. Whenever alternative hypothesis doesn't equal to some value, then you are going to have a two-tailed test. Okay, now let us draw a picture of this. Will have a normal distribution. Okay, and we have some shaded area over here in the left side and shaded area in the right side as well. Okay, and what does this shaded area mean? See, basically this is a two-tailed test. How it looks, we in two-tailed test we have got shaded areas on the either side, on the left and on the right side. Now this shaded area, it actually represents rejection region, and the area which is not shaded, that is the middle part, it means fail to rejection region. Now the Z value will separate these two regions, the rejection region and fail to rejection region. These value means this will be separated by the Z value, and the Z value, it is known as the critical values. Now let us say that the worker conducts the test at a 95% of confidence level. 95% confidence level means C will be equals to 0.95, and we know that C plus alpha is equals to 1. Okay, level of confidence plus level of significance is equals to 1, and therefore value of alpha is equals to 1 minus 0.95, which equals to 0.05. Now because alpha is split into two regions, then the right side will be alpha by 2 and the left side will be alpha by 2, which will be equals to 0.025. Okay, so 0.025 in the left and 0.025 in the right. Together the value of alpha will be 0.05. Yes, and the middle area will be 0.95. Now, in order to determine whether you should reject or not reject the null hypothesis, you need to calculate the Z value and compare it with the critical value. Now, suppose if the Z value is greater than critical value, then reject the null hypothesis. You need to reject the null hypothesis. Why? Because it will come under the rejection region. Okay. Now suppose, let's say, if the value of Z is not coming in the rejection region, then do not reject the null hypothesis. You should keep it. Okay. So we'll talk about this calculation of Z value in another video. Okay. So for now, we'll discuss about the one-tailed test. Okay. So one-tailed tests are of two types. It could be a left-tailed test or it could be a right-tailed test. Now suppose when the C level was 0.95, that means the value of alpha will be 0.05, isn't it? Now suppose for a left tail test, the value of alpha will be completely in the left side, isn't it? Because it is a left tail test. Now when to use this left tail test? So let us say that the alternative hypothesis says that the weight of the cup ice cream is less than 5 gram. So if it's less than some number, then you need to use the left tail test. And if suppose the null hypothesis says that the weight of cup ice cream is more than 5 gram, then in that case you need to use the right tail test. Okay. So when it is less, then left side. If it is more, then right tail test. Very simple. Next, we'll have one more example to differentiate between one and two tail test. Suppose the boy thinks that the food is tasty, and when the food is tasty, he will eat more than what he was eating in a regular basis. Okay, then this is an example of a right tailed test because he is eating more. Okay, the hypothesis is he will eat more than the normal amount that he will be eating. Next, suppose this boy thinks that the food is not tasty, then if the food is not tasty means he will eat less, he will eat in the very negligible amount than he is actually eating on a normal basis. Then here we'll be having a left tail test. Okay, why left tail test? Because the hypothesis will be he'll be eating less. Suppose here this person, he feels that the food is very tasty but he is on a diet, so he may eat or he may not eat. We cannot predict. He may not eat because he is on diet, but he may eat because the food is very much tasty. So we cannot say exactly what he may do. He may eat or he may not eat. Either will be the prediction. So alpha value will be on both the sides. So here we'll have a two-tailed test. Okay. See, in practice, we should use a one-tailed test only when we have a good reason to expect that the difference will be in a particular direction. Like here in our example, when the food is tasty, we'll have a right tail test. The food is not tasty, we'll have a left tail test. But whereas in case of two tail test, it is more conservative than the one tail test because a two tail test takes a more extreme test statistic to reject the null hypothesis. I hope, I believe you people understood the difference between one-tailed and two-tailed test. Okay, so this was all about our today's video. I hope you people found this video helpful. Thank you for watching.